pesticides has been linked to a global decrease in insect populations, with serious consequences for biodiversity and essential ecosystem services. In addition to the immediate effects of pesticide use, there may also be delayed effects from past exposure at different stages of a bee's life. These carryover effects can further worsen the impact on individual bees and bee populations. Today, our guest is Dr. Clara Stuligross, a postdoctoral scholar at the University of California, Riverside. To start off with, I asked Clara to tell us a bit more about how pesticides harm bees.
That's a great question. So I guess I'll start a little bit by talking about pesticides in general. Pesticides are chemicals, most usually chemicals that are intended to kill some kind of pest. And so these are used pretty widely, especially in places like agriculture, to control pests like insects or weeds or basically things that get in the way of this sort of crop or food production. They're also used in a lot of other situations around the home, in cities and things like that, to control rodent pests and all sorts of things you might imagine as animals in life, that is places where you don't want it. And when we think about bees, we know that bees encounter these pesticides in the environment throughout their lives. So they spend most of their adult lives flying around foraging for pollen and nectar from flowers. And then if those flowers or other things they come into contact with get sprayed with pesticides, or if they absorb pesticides from the soil, bees can be then exposed to those by touching the flowers or by collecting that pollen and nectar that might contain pesticides and eating it themselves or feeding it to their offspring. And once they're exposed, pesticides can affect bees in a number of different ways, depending on the type of pesticide and the type of exposure they received. But because they're designed specifically, in many cases, to kill insects, there's a number of ways that they sort of work with the insect body in bad ways. So this can cause immediate death if they get a really strong dose. But often what we think about when we're doing research is these sublethal effects, which means it doesn't kill the bee outright, but it can make them sick in different ways. It can affect their nervous system, it can affect their ability to sort of think and make decisions, and affect their physiological system so the bee can't really perform normally.
So as you mentioned, bees are directly exposed to pesticides as they forage, but your study considered the carryover effects of past exposure. What does that mean?
Yeah, so I just talked about a few of the different ways that bees can be exposed to pesticides. And I think one thing that's really important is that in the environment, these exposures can happen multiple times and they can have a long-term impact over time. So thinking about agricultural environments again, or even in a lot of home gardens or other places like golf courses where pesticides are applied throughout the year and then year after year. So we know that pesticide exposure can happen at multiple stages of the life cycle and over multiple generations for these bees. And I noticed that most research with wild bees and sort of our understanding of how pesticides are impacting bees really only looked at impacts of one exposure or sort of just exposure during 1 year, which I think could really miss the full impact because of these multiple exposures, because of the long-term impacts of exposure. And so I designed a study alongside my PhD advisor, Neil Williams, and we wanted to look specifically at these carryover effects, which is basically an ecological term that means when your past experience or exposure to something impacts your current performance or health. So, for example, if a bee was exposed to a pesticide as a young bee, like as an immature bee, a larva, and then grew up to be an adult bee, and then as adults, they suffered negative consequences as a result of that exposure, that would be a carryover effect. And this can also happen if like a mother bee is exposed and then her offspring suffer consequences as a result of the exposure in the previous generation. And so in the wild, this could happen if bees were exposed to pesticides in 1 year, but then in the next year they weren't exposed. What kind of impact does that have in comparison to a bee that might have been exposed for 2 years in a row? All the combinations of things that might happen in this messy environment where bees and everyone is sort of experiencing things differently over time.
So thinking about this messy environment, how did you go about conducting the study?
Yes, that's a great segue because, yeah, the environment is really messy. There's all sorts of variables that can make it hard to do science in a controlled way when you're sort of in this wild world. And so what we actually decided to do to really look at these questions in a more isolated environment was to do it in cages. So we set up these really large flight cages outside at our field site in California. It's basically sort of a metal frame with mesh on the outside. So they're still interacting with the outside environment, the sun, the wind, but they're contained so that there's not interference from other factors like parasites or other types of bees or predators or things that could affect the dynamics within the cages. And then inside each cage, we planted a bunch of wildflowers. So bees essentially had like a full garden, as much food as they could possibly want. And I study a solitary cavity nesting bee. Sometimes they're called mason bees, called the blue orchard bee. The scientific name is Osmia lignaria. There's a lot of osmia, bees in the Osmia genus in lots of areas in the world, but this is the one that's native to, one of the native ones to the western United States. And what they do is they make their nests inside pre-existing tunnels. So in nature, these are sort of things like abandoned beetle burrows in wood or twigs that have been hollowed out, things like that. They'll find something that kind of looks like that, and they're really great for research because they actually will readily use holes drilled into wood that kind of mimic what they would find in nature. And what we do is we drill holes in wood and then we line those holes with like paper drinking straws. And then they'll make their nests in there and we can kind of remove those nests and work with them and sort of measure how far their nesting progression is. And it works really well for research study. So I had these cages filled with wildflowers, and each cage had a nesting block filled with these paper straws, so bees could nest within them. And then I released bees into each of the cages. And in half of the cages, I applied a pesticide treatment, and half of the cages we left totally alone, sort of as the control to compare to. And then throughout the spring, these bees are nest in the springtime. We measured all sorts of different things within these cages. We watched the bees and saw sort of what their nesting behavior looked like, how fast they were constructing their nests, if there seemed to be any issues with foraging. And we also counted the bees' overall reproduction. So how many offspring did each bee provision in those nests? And then just general other details about their nesting activity. And we actually did this for 2 years in a row. So that's sort of to try and get those carryover effects. So we did it for the first year. And then in the second year, we took the offspring from those bees in the first year and we put them back into cages. And we basically split the offspring into what we call different treatments. So we had groups of bees that received 2 years of exposure. So in both years, they went into the pesticide cages. We had some bees that only received 1 year of exposure. So in the first year, they might have had pesticide, and then the second year, no pesticide. Or the opposite, where the first year they had no pesticide and the second year they did have pesticide. And then, of course, we had bees that had 2 years. We had bees that had no exposure, so they were not exposed in either year. And this allowed us to compare sort of what happened with every combination of what bees might experience in the environment. And I think based on past research, I was definitely expecting to see a result sort of in the current year of exposure, a 1 year effect, because that's kind of what most research has shown. But I really had no idea if we would see a second year effect or not, or what would happen if bees had sort of a mixed exposure, like in 1 year they had exposure and the second year they didn't. So I was really excited to see what would happen.
And so what did happen?
Great question. So we found overall that the pesticide exposure had a really big negative impact on reproduction. So it actually dramatically reduced bee reproduction. And that was in sort of a few different exposure scenarios. So this happened to bees in the first year. So in the very first year of the study, all bees that experienced pesticide exposure produced fewer offspring. But this also happened to bees in the second year. So we found that pesticide exposure did carry over to impact bees at a later life stage. It's a little bit complicated to kind of explain all of the different combinations of exposure, but bees that were exposed in the first year and then did not have any exposure in the second year also produced fewer offspring. So this kind of shows that carryover effect where we know that even that past exposure, even if they were, in their next year they were to have a really good environment with no exposure at all, they're still going to suffer the negative consequences of that prior exposure. And then, of course, bees that received 2 years of exposure, which is actually a pretty common scenario in many environments, especially in intensive agriculture where these pesticides are used year after year, they had an even more dramatic reduction. And basically the effects were what we call additive, meaning that the negative effects from the first exposure added on to the negative effects from the second exposure, resulting in an even bigger impact. So yeah, the repeated exposure across 2 years had the worst effects, and it led to almost a 4-fold reduction in population growth. So each additional exposure further reduced their reproduction.
Was that surprising to you?
I think I was very surprised at the magnitude of the impact. I'm never surprised really when you poison bees and they don't do so well. That's pretty expected to some degree, but sort of seeing how far it carried on into the future, I think was definitely surprising to me.
Why are studies like this so important in the face of pollinator decline?
I think it is really important to understand the long-term implications of stress. And so for this study, I looked at exposure to pesticides, but any study looking at things that contribute to decline, understanding how these things impact bees long-term, can really provide a fuller picture of what to expect in the future. And so based on our study, I think it becomes even more apparent that we need to reduce bee exposure to pesticides. It could be important to incorporate these longer-term effects into risk assessments that are used to determine sort of the rules for applying pesticides. And there's a lot of current work to integrate risks to bees into pest management strategies. So when farmers and growers in agriculture are determining sort of how to best control pests in their area, I think about this a lot in agriculture, but it happens in lots of other systems as well. It can be really important to understand how this pesticide application across landscapes actually corresponds to exposure to bees. And I think this work is really important that can allow more practical actions to mitigate these risks. And so, yeah, I think studies like the one I did contributes to a better understanding of the way that pesticide exposure affects bee populations over time. And yeah, it really supports the idea of reducing exposure as much as possible and also incorporating these carryover effects into pesticide risk assessments so we can hopefully reduce any negative effects into the future.
And do you see agricultural areas thinking about their pesticide use, how it affects other organisms, and consciously looking to reduce it?
I think that is very common. There's an approach called integrated pest management, which essentially is trying to use pesticides as just one tool in sort of a larger arsenal of tools to help control pests in a crop field, in an agricultural system, and making sure to only use them when they're absolutely necessary and when they'll have the biggest, sort of most targeted impact. And I think a lot of industries are really, really valuing bees in agricultural ecosystems, but it also can be very complicated because a lot of the pests in agriculture are insects, and you kill insects with insecticides, and bees are also insects. And so trying to figure out how to have sort of a more integrated pest and pollinator management strategy, I think the desire for this is growing, but it's just a difficult situation. And so it's hard to really, I guess maybe this is all to say that this is why it's really important for us to do more research like this so we can understand how to better protect pollinators in these systems, recognizing that sometimes pesticides need to be used for food production.
Do you have a favorite bee?
I have a hard time picking favorites, but if I had to pick one, I probably would pick the bee that I studied for this work. It's called Osmia lignaria, the blue orchard bee. It's sort of a bright, like metallic blue color, and they're really charismatic. I really enjoyed working with them, and I'm always really excited to see one out in the wild in nature.
What do you think is the biggest threat to bees, and what can we do to help?
I think bees are threatened by a lot of different things. The two biggest ones that come to mind are habitat loss and climate change. And habitat loss tends to also coincide with other types of land use change, like agricultural intensification, which can lead to, and urbanization, which can lead to exposure to chemicals or diseases or things like that when that habitat loss occurs. But I think these all kind of go hand in hand. And what can we do to help? There's a lot of research that shows that the more flowers there are in the landscapes, the better it is for bees. So planting flowers and not using pesticides on those flowers or not using pesticides in your garden is the best way that an individual person can support bees. But more broadly, I think larger scale efforts to reintroduce native habitat into existing spaces and also to limit climate change on a national or global scale is really essential to supporting pollinators and also all of the other life on this planet. So there's sort of like things that you can do sort of within your own little sphere, but then also actions you can take to help support or encourage policies that will have these sort of massive, more global effects.
My thanks to Dr. Clara Stuligross for the insightful discussion and her efforts to raise awareness about the harmful effects of pesticide use. If you enjoyed the show, please follow or review it on your favorite podcast app and share it with a friend. Thanks for listening, and until next time, keep buzzing.